In this video, we are going to look at some additional practice problems. You should already have attempted these problems on your own before starting this video, or it will just be a waste of time. You want to use this to determine if you made mistakes, what those mistakes were. Let's look at some practice problems. Our first problem, take a minute to read, pause if you need to. Our first problem asks, how many moles of iron sulfate are in 125 milliliters of a solution where, remember the square brackets mean the concentration of, but also that is the molarity of the solution, is equal to 0.0530. So we've got our equation for molarity, and it's asking us for moles. So if we have our volume from our problem, 125 milliliters, we can use our molarity to convert to moles. So let's try that. Now, one of the issues that we have is that, remember that molarity is equal to moles over liters, and we have been given our volume in milliliters. So what we will want to do is go ahead and convert that to liters. We can do that as part of our factor label. So we start with 125 milliliters of FeSO4, and we set up our factor. And in order to go from milliliters to liters, we want milliliters on the bottom, and we want liters on the top. Our scientific notation for milli is 1 times 10 to the negative 3, and we want to put that with liters because liters are our base unit, our unit without a prefix. And then now that we've determined our liters, we want to go from liters to moles using molarity. Erase that, I got carried away with the pen. So we're going to want liters on the bottom, liters of FeSO4 on the bottom, and we're going to want our moles on the top. We want to go from liters to moles. Remember that we are using that molarity as a conversion factor because the molarity is the moles divided by the liters. So in this case, we have 0.0530. I'm going to come over here and write that so I have room. 0.530 moles per liter. So that's the number of moles in 1 liter. So we want to put our 0.0530 with our moles and our 1 with our liter. Now you should be calculating this on your calculator if you did not get the answer correct the first time you worked the problem. And you should get 0.00663 moles of FeSO4. And remember that your answer will have 3 significant figures, just like your numbers from your problem. There are 3 here, and this one also has 3. Remember, those first 2 zeros are not significant. Let's try the next problem. In this problem, we've got 15.5 grams of barium chloride, and it's dissolved in enough water to make 150 milliliters of solution. So we're being asked to find the concentration, remember concentration in chemistry is molarity, of barium chloride, BaCl2. So we need to set up our equation. Molarity equals moles over liters. And we need to look back at our problem. We don't know the moles. We've got a mass here and a volume here. But if we have the mass, we know how to use the molar mass to convert to moles. And we have a volume here, but our volume is not in liters, so we don't actually have the things to start with. We're going to have to make some conversions to do that. So let's come over here and start with let's deal with our volume first. We've got 150 milliliters. Can you tell that I'm having pen issues? So we want to go from milliliters to liters. So we want milliliters on the bottom, and we want liters on the top. And we want to use our scientific notation for milli, which is 1 times 10 to the negative third. It needs to go on the top with the liters because that is our base unit. It's the one without the prefix. And that should give you 0.15 liters. And then for our moles, we have to start with our mass, 15.5 grams of barium chloride. And we want to convert that from grams of barium chloride, so we need that on the bottom, to moles of barium chloride. Getting a little messy there. So moles of barium chloride. And so here we're going from mass to moles. We want to use our molar mass. Remember that you have to calculate your molar mass of barium chloride by adding the masses of 1 barium and 2 chlorides. You need to stop and do that now if you haven't already done it. And you should get 208.28 grams. Remember that the molar mass is the number of grams in 1 mole of barium chloride. And I'm going to come down here and write my number there. And that would give you 0.0744 moles of barium chloride. Now remember, we round it to the correct number of sig figs, but you want to keep that entire number in your calculator so that you don't end up with a rounding error. So leave that whole number, whatever is beyond that 0.0744, in your calculator. Now let's come up and set up this equation now that we have the information we need. We have our moles of barium chloride. And we have our liters. And so if you put that into your calculator, you should end up with 0.50 moles per liter of barium chloride. And if you're asking yourself about the 2 sig figs, remember that there are only 2 sig figs here in your volume. You can also write this as 0.50 molar barium chloride. Let's try one more. Go ahead and read the problem. Pause the video if you need to. In this problem, it's asking us what volume of 0.100 molar ammonia solution contains 4.95 times 10 to the 23rd ammonia molecules. So we're being given the molarity. So using the molarity, we know if you look at the flowchart, we can use molarity to find volume. But since that's the last thing that we're being asked to find, the volume, we know that we're going to use that somewhere at the end. We need to start over here with molecules and convert molecules to moles, and then we'll use moles to convert to liters using molarity. So let's go ahead and set that up, starting with our particles. So we've got 4.95 times 10 to the 23rd ammonia molecules. Hopefully you remember that the formula for ammonia is NH3. And and we want to go from particles to moles using Avogadro's number. So we need molecules on the bottom, and we want to convert to moles, so we're going to moles of NH3 on the top. And looking at your reference table, you know that there are 6.022 times 10 to the 23rd molecules or particles in 1 mole of anything. So now we have moles, we need to get to volume, and we're going to use molarity as a conversion factor to get there. So let's set up our other conversion factor. Now in order to go from moles to liters, we're going to need to put moles on the bottom, moles of NH3, and we're going to put liters on the top. So if you look at your molarity, remember that that's 0.100 moles per liter, or the number of moles in 1 liter. So 0.100 moles in 1 liter of ammonia. Go ahead and pause and put this in your calculator. You should end up with 8.22 liters of ammonia.